A very good evening to one and all present here. We welcome you all for match 6 out of 10 of CYBER T20 Series V3. So you've already had 5 matches. You might have had different domains, different speakers with respect to cybersecurity, cyber forensics, and mixer. So today we are just having match 6. And we have our esteemed speaker, Mr. Samir Dutt. So we'll start with a short intro about our speaker. Samir Dutt sir is the founder and CEO of forensicguru.com since 1999. I hope most of us are students here from student community. We can just remember what we were doing way back in 99, right? So sir started his first company on digital forensics in 1999. He has 30 plus years of experience with clients with US, UK and India. He's the president of Digital Investigation Association. He's the author of the book Learning Network Forensics from Packet Publications. He's the alumni of NIT Roorkee, IIT Kanpur from IIFT Delhi. He's also a fellow of Indian Police Foundation, a TEDx speaker, visiting faculty in NPA Hyderabad, CBI Academy, NICFS Delhi, and many others. The most important part is he's also an angel investor for product startups in cyber forensic and investigation field. So with this short introduction, we welcome Samir Dutt sir for match 6. Welcome you, sir.
Thank you.
Fine, sir. So we'll just share your presentation.
Please.
I hope the screen is visible, sir.
Yes, it is visible.
Thank you, sir.
Am I audible, loud and clear?
Yes, sir, you're loud and clear, sir.
Am I visible?
It's a bit of, yes, sir. Now it's clear, sir. It's centered.
Okay, perfect. So good evening, everyone. I can see a dedicated lot of people on a Sunday evening who are, taking time out of their holiday to be present here. So welcome to all of you. It is a pleasure and an honor to be here, and thank you so much for inviting me. Let's get started. This is a small video. With your permission, I'd like to, just play this video and give you a little bit of an insight. Not this one, the next one. This I did, yeah, this one. Yeah, so please go ahead. It's an introduction to our company.
Just a minute, sir.
No sound, can't hear any sound.
Just a minute, sir. Let me enable the sound. Sir, you're muted, sir.
Sorry. Yeah. So thank you for watching. You live in a digital age. I live in a digital age. We all live in a digital age. So we don't have an option. We have to, start worrying about digital crime, and it's a lot more costlier. And it is a multi-jurisdictional issue with nation boundaries being a problem, and most of the crimes are underreported. And there is of course a lack of awareness, and late reporting is a big problem. In fact, most of you must have heard about the CERT directives that have gone out to corporates, wherein every corporate is required to report a breach or even an attempt at a breach to the CERT, which is the Computer Emergency Response Team of India, within 6 hours of it happening. So this is a huge compliance burden on organizations and a big area of concern. Though from a job perspective, from an industry perspective, this is a growth area. But from a corporate perspective, this is an area which is like going to create a lot of issues going forward. Next, please. Next slide, please. Yeah. So let's take a look at the recent situation and the future. Next, please. There are a lot of things that are out there that are digital in nature. IoT is a mega thing. We've all heard of the Mirai botnet, where this botnet was used to carry out an attack on an electrical grid, a telecom network, and a lot of other things, and caused extensive damage. In fact, I don't know if you're aware, one of the founders was a person from India. Well, I mean, one of the Mirai writers was a person from India. Next, please. Images and video quality is getting manipulated easy. Here we are seeing 4 images, and deep fake technology has been used to create these. And I don't know if you're aware, how many do you think out of these are genuine? Or rather, which is genuine and which is fake? You can write it in the chat if you like. This is going to be part of your quiz.
Yeah, participants, if you have any answers, you can just put it in the chat box, like 1, 2, 3, 4, which one you feel it's genuine or things. Okay, someone are replying.
Yeah, good. All right, good. So Harsha is the bold adventurer. He has said third is real, and Vedant is not taking any guesses. He is saying can't be determined manually. Anybody else? Third, Simmerpreet. Okay. What else? Anybody else? Okay, so I'll make it easy for everybody. All 4 are fake. If we go to the next slide, you'll see the real one. This is the real one. So as you can see, it is extremely difficult to tell what is real, what is fake. So, we need to be able to separate the real from the fakes. Next, please. Privacy is getting big. Passwords are getting stronger. So what is happening is that any file that you see which is protected with a password is no longer going to be protected with a small password. No 4-digit, 6-digit, 8-digit passwords. People are putting in complex passwords. And not only complex passwords, they're also putting in all sorts of special characters and using password phrases. So the complexity of passwords is increasing, and from a digital forensics or a forensics investigation perspective, what is happening is that we are seeing that it is becoming more and more difficult to crack passwords. Next, please. So decryption technologies have to move out of the conventional mode, and the brute forcing and the GPUs that we were using to crack passwords, etc., will no longer be enough. So we have to move into quantum computing to be able to crack passwords that are very complex and difficult to crack. Next, please. Personal devices, our lives are there in our phones. in fact, today, if somebody loses a computer or a laptop, they are less worried than when they lose a mobile phone. Even though the cost of the laptop might be more than that of a mobile phone, but the value of the data in a mobile phone is a lot higher. If you agree, please type yes. Let's have a little interaction, my friends. Good. So our ability to get the data from these mobile phones is even more crucial. And today, due to the encryption, due to the passwords, it is a lot more complex. So we need to have the capability to get the data out of these mobile phones, even if they're damaged, even if they're password protected, even if they're fully encrypted, right? Next, please. Another thing that we are seeing is that, police forces, investigators have been using CDR analysis. So, in the UK, whenever a king or a queen passes away, they say the king is dead, long live the king. But the second time the king is said, that is for the new king, So, like just when Queen Elizabeth passed away, so they said the queen is dead, long live the king, because Prince Charles became King Charles. So, CDR analysis was the king for the investigation world. But CDR analysis is dead. Most people are now no longer making normal phone calls. They are making, WhatsApp calls. They're making voice over IP calls. They're using apps. They're using a lot of other things. So IPDR is the next big thing. IPDR is the mode of communication. IPDR is the way to analyze whatever is going on mobile phones. Next, please. Next, please. So what we're going to see is that the market is going to increase to $7 billion by 2025, which is a lot. Next, please. And another thing that we are facing is hard drive sizes are increasing huge. We are seeing hard drives in terabytes, but not normally terabytes. And if you go and build a laptop or desktop today, you can get a 4 terabyte hard drive. Laptops are coming, with 1 terabyte standard, and we are seeing devices with 12 terabyte hard drives in it. Next, please. The file system types are huge. There are a lot of different file systems, and we are, seeing more and more file systems. Next, please. Next. And there are RAID arrays, there are external devices with storage. So when it comes to digital forensics, we have to be able to cater to all these things. There is data stored in monitors today. There are TVs that come with built-in Androids and storage and hard drives and normal hard drives, of course. Then there are dual hard drives that you will find a hard drive which has got another hard drive with it, and we've even got hard drives that can be plugged into the back of a PC, inside a PCIe card. So it goes in like a cartridge or a floppy. The whole hard drive is plugged in, and it's a PCIe hard drive. And you can press it in and it starts working. You press it out and it comes out. So things have really, become complicated and different. Next, please. Different file systems present different challenges. There are compression has become huge. Encryption has increased a lot. And there are a lot of new file system technologies coming. Now, every new version of an operating system, like Windows 9, Windows 10, Windows 11, all that, they come up with new challenges and new artifacts. So, from a digital forensic perspective, what happens is that we have to learn to be able to handle the new things that are coming, the new artifacts that arrive on a computer whenever it comes with a new operating system, and that is what we use for the purposes of investigation, right? Then there is storage of data, which is offsite storage, and there is on-site storage, and then there is internet traffic. There are even situations where email has to be analyzed, and it can be a huge amount of email. It could be something like extremely high volumes of PST files or EDB files and things like that. And those huge numbers of files that are out there could actually need to be data mined, and each say email can be with an attachment. There could be a zip file. Within the zip file there could be this. All of these actually have to be imaged. Normally, when we do image file, we do it in the encased image file format. and that is something that we then do an analysis in that. That is the E01 format. Okay, next please. Data encryption is another problem. There is data that is stored, in encrypted format. There is data that is, we need to get data out of things like the, registry of a Windows computer, where, the data is stored in the config folder within the Windows directory structure. The, the number of registry files like the SAM file, etc. That's the security account manager. And, things like the sizes is going up. The criminals are understanding that they have to eliminate data. There are anti-forensic groups that are out there that teach you how to eliminate data. You remove data, and rather than just deleting or removing data, you can even manipulate data. So the data that exists can be actually, rather than just deleting it, if somebody changes a small number here or there, and instead of 1 lakh it makes it 10,000, or instead of 1 lakh it makes it 10 lakhs, it changes the meaning of the whole thing, and that becomes really complicated. So no criminal wants to get caught. They all want to sort of avoid getting caught. So they will hide their trails, they will encrypt their data, they will hide their data. Let me give you a real world example. So suppose I have a top secret file and it is called mysecrets.xls, and that is lying on the desktop. As an investigator, if you are passing by, you see that file, you will double click it and it will open, right? So I'm a smart criminal, so I will say, why should I call my file mysecrets.xls? Why don't I rename it to windows.dll and copy it into the Windows system folder? When I do that, I copy the file into the Windows system folder. What happens? First, nobody knows where it is. Second, it is not called an Excel file. So only when I want to see the file, all I have to do is go to the Windows system folder, look for the windows.dll file, do a right click and open with Excel. For the rest of the world, the file may not exist, and it's going to be difficult to get. So all this requires advanced tools and technologies that can automate the process, because there are lakhs of files on any computer. So anybody who's doing an investigation needs to be able to solve these kind of problems, right? Okay, so let's move on. Could we go to the next slide, please? We'll talk about the tools and technologies. The first thing is, when we arrive at a crime scene, when we're doing digital forensics, we need to carry out a seizure, right? Because what happens is that when we are going there and we want to grab the digital evidence, we want to grab it in a manner that it does not get changed. So we are using devices that right block the seizure so that the content does not change. Even a single date or time, if it changes, then our evidence has been manipulated and it will not be accepted in a court of law. So to do that, we have what we call the digital evidence seizure kit. It allows us to go to the scene of the crime, use a right blocker, preview the content and seize it, or use a Faraday bag which prevents the data from being modified inside a mobile phone or a tablet and things like that. Let's take an example. Suppose I have a 100 GB hard drive, and out of the 100 GB hard drive, say 2 GB of it is only occupied. But when it comes to forensics, I cannot work with only the 2 GB of data that is visible, because there could be a lot of data that is deleted and it is not visible now, but forensically I will have to take the whole 100 GB. So if it is a 100 GB hard drive, I will have to create an image of the full 100 GB to ensure that nothing is missed, including the hidden and the deleted data. So what is visible is not good enough, because as a digital forensic investigator, what we have to do is we have to do a deep dive. We have to get in with the bits and bytes and extract the data that we need, right? Okay, so next please. So you can use this. We can create seizure memos. We work as per Indian law. We take photographs of the crime scene. We document, we bag and we tag and we transport digital evidence from the scene of the crime to the laboratory where we do the analysis. Next please. And next please. So this is what a seizure memo looks like. Basically, you need to be able to document your complete process, and when you do that, only then and then only is your case going to work in a court of law. Next, please. Now, we talked about IPDR and we said the king is dead, long live the king and everything. But before we even, start using CDRs and before we start getting IPDRs, we need to be able to identify what actually is happening at a particular location. And we want to identify if a crime has occurred in a particular location. We want to know who was present at the scene of the crime at the time of the crime. So to do that, we need to identify what are the cell phones that were present at that time. To identify the cell phones that are present there, we need to identify what are the cell towers that are in that area which cover that location or crime scene, so that the towers can tell us, look, this cell phone was present at the time of the crime, at the scene of the crime. So this is something, which is extremely important. We need to identify the correct towers. And to do that, we use a device, it's a hardware device, it's called a cell site analyzer. Next, please. Next, please. So this is what it looks like, it's pretty simple. You just go click, next. And what it does is it will get all the cell IDs, it will get all the nearby towers, and it has got a GPS, and it will identify the, lat long of the place where the crime has occurred. So very useful. Next, please. So after this first step is done, and you will get a reading like this, where it is showing you all these cell towers, their cell IDs, their service providers, their region, whether it is 2G, 3G, 4G, 5G, whatever, the signal strength, etc. Then what you will be able to do is that you will be able to put in a request to the service provider, say, give me a tower dump of all the data, all the people who were present there, who were using their internet, who were using WhatsApp, who were using Facebook, who were using Google, who were using Ola, Uber, and utilize that to do analysis. Next, please. So this is, for CDR analysis. Next, please. Where we can analyze, all sorts of logs. Now, what is a log? A log is a transaction. When you or I communicate with each other, or even when we don't communicate with each other, when we connect to the internet, when we make a voice over IP call, when we use Telegram, when we take Rapido, or we do some online shopping on Amazon, or we order some food by Zomato or Swiggy, whatever we do, some records are created with these service providers. So these are different categories of records. When we make a call detail record is created. When a tower is analyzed for activity, that is a tower dump record. When the IPDRs, internet activity is analyzed, the records that are created are called IPDRs, or Internet Protocol Detail Records. When international calls and international activity is done, then there are ISD dumps created. When gateway activity is done, which is activity between multiple nations, then gateway CDRs are done. And when we carry out, say, subscriber analysis, where when you register yourself to a mobile phone to buy a mobile number, what happens is that they do a KYC. So everybody gets a KYC done, in the sense that they provide some identity documents. Sometimes you and I, we will provide real documents, and the criminals, etc., will provide fake documents. So in such a situation, what will happen is that there is something called a subscriber detail record created for every subscriber. So these are also analyzed for the purposes of investigation. Next, please. Normally what happens is that we have a framework which we call the alibi framework. Now here, in this, we analyze the associations or actions of a suspect, identify their locations, we analyze to see what information is there that will help us find that person's identity. We will focus on the behavior, what is the kind of activities that person is doing and things, and what is the intent. So the ALIBI, and all of these are used to investigate a suspect. So on this basis, all the evidence collected from a digital forensic investigation can be classified into these categories. So similarly, suppose we are looking at locations. So using this technology, and I gave you the example of the cell site analyzer and the CDR and IPDR analysis and things like that, we will be able to determine the presence of a person at the crime scene. We will also look at some places that a person usually visits. Where does he, go regularly, right? Then what are the places that are common with other criminals, right? What are the travel routes a person takes? Or if we look at associations, we'll find friends that someone might hide with. What are the friends a person is hiding with? What is the family he is always in touch with? Who is his girlfriend? Who is his wife? Is he a small-time criminal? Is he a local criminal, national criminal, international criminal, etc.? So all these factors come into play. Also, we can analyze the person's behavior. Where does someone sleep at night? What is the type of phone device he carries? So does he change his SIM? Does he communicate with calls or text messages and things like that, right? Okay, so for CDR analysis we use a tool called CDAMS, which is basically Call Data Analysis and Management System. It is a tool which allows us to extensively handle very large volumes of data, and CDAMS is for CDR analysis, tower dump analysis, and things like that, right? Okay, so next please. It can handle data from multiple sources. You can get cell phone records, tower dumps, landlines, internationals, IPDRs, SIM cards, gateway, subscriber details. You can even get data from mobile phone forensic tools like UFED, XRY, Tarantula, etc., and interception devices, and get that into CDAMs and analyze it. Next, please. So the flow is, we will get the dump, we will analyze the different data formats, we will then produce output in terms of association and link charts, we will plot movement and locations on a map, we will do analysis to look for commonality, we will look for who are the people present at the same location at the same time, or do both the suspects know the same person, and things like that. Next please. Quick overview of a case study.
Welcome back to another case study. This time, it's all about how CDAMS was used to zero in on criminals involved in hijacking cash vans. An ATM cash van was hijacked while refilling cash points in a rural community. The cash van was found later, abandoned, close to a housing block, not far from the highway. Obviously, the contents had been transferred to another vehicle at this point. Independent witnesses claim to have seen a cash van speeding along a particular route at the appropriate times. The investigating team was quick to press CDAMS into service. The cellular masts covering the hijack point, the travel route and the vehicle drop-off point were identified. Cellular providers were requested 4-hour logs for the period of the heist. As is common, they were provided in a multitude of formats, all of which CDAMS ingested with ease. The intuitive CDAMS interface allowed the investigating officer to create a case specific to this crime in a few seconds. All ingested data was added to this case for analysis. The idea behind this was to identify cell phone users who were present at the crime scene, the route of the hijacked van and the place of its abandonment. CDAMS was used to analyze the ingested cellular tower data. Numbers common to the cellular towers were identified. Movement along the route observed by eyewitnesses was verified. The investigating officer zeroed in on one number meeting these criteria. This was present at the crime scene, as well as the hijacked van's travel route at the appropriate times. The investigating officer now had a suspect. The next step was to request the cellular service provider for specific subscriber data as well as call detail records for this number. Unfortunately, the SIM card was a prepaid, or pay-as-you-go SIM. The subscriber data associated with the number drew a blank. However, CDAMS made the call records sing. CDAMS identified all the associates of the criminal, some who were cross-border as well as others who were also at the crime scene. A surveillance operation helped nab the gang. To see how CDAMs can help enhance your investigations, please visit www.cdr-analysis.com. Welcome back to another case study. This time, it's all about how CDAMs was used to zero in on criminals involved in hijacking cash vans. An ATM cash van was hijacked while refilling cash points in a rural community. The cash van was found later, abandoned.
Ashok? Yeah, thank you. So we also have to analyze large volumes of internet data. So IPDAMS is the tool that we use it. The whole thing is that in this we are able to identify, say suppose you and I are having a WhatsApp call. This will help identify who's the other party from getting the CDR of just the first party, IPDR rather. So this is something that is very unique and very special. It allows you to analyze the other party of the voice over IP call. Next, please. It can help you identify the applications being used. So when we are seeing that, say somebody is using, say, Facebook or Bottom or Telegram or Amazon or Geo, Signal, Apple, all these different things that are being used by people on their mobile phones, and this activity can be analyzed. Next, please. You can analyze timeline, the various activities that are done, first this, then that, or by volume, like, okay, the huge activity is related, basically the first level of activity is all Google, then the next is Facebook, and then it is Bottom. Now Bottom is like WhatsApp, but it is used extensively in the Middle East. So if you are in Dubai and you want to make a call or you want to use chat, then you will use Bottom rather than WhatsApp, which is blocked. Next, please. And you can look at frequencies and things. Next, please. The next is that next, please. When we do investigations, I think we missed a slide. Can we go next? Ashok, next. Yeah. Then we look at intelligence analysis tool, the IIMS, Intelligent Information Management System. When we do crime analysis, incident analysis, or whatever, we get information from multiple sources. We get information from logs. We get information from access logs. We get information from CCTV cameras. We get information from vehicle databases. We get information from the RTOs. We get information from interrogation reports, status reports, intelligence reports, etc., etc., etc. So when all that information is collected and got, what normally happens is that it's a big mess. So this actually takes all that information, puts it together. Anything that is geotagged is put on the geographical on a map. Anything that is linkable is linked, and all that information is put together in a format that can be easily understood. Next, please. So here you can see it in a graphical format. It shows these are the suspects who are associated with each other. It shows the different activities that they were involved in. It shows their movements. It shows their locations, where all they have been on the map and things like that. Next, please. Then let's talk a little bit about the gold standard when it comes to digital forensic of media. That is called NCASE. NCASE allows you to triage, collect, decrypt, process, investigate reports. So NCASE creates normally by default image files in the E01 format. It's called E01 because the file extension is E01. So that is the NCASE image format. And the key thing about it is that there are a number of forensic tools out there. There's the forensic toolkit, there's NCASE forensics, there's Belkasoft Evidence Center, etc. But all of these forensic toolkits that are there all do similar stuff. NCASE has been around for a lot longer, and it allows you to go in a lot deeper. So that is why it's currently the market leader. But it is something that can be extensively used for analyzing all types of media. Not just hard drives, but it can also be used for mobile phones, it can be used for GPS devices, it can also be used for drones, etc. However, when it comes to GPS devices, the main tool for GPS devices is Burla Blackthorn. So we don't use other tools for that. It is Burla Blackthorn that is used for GPS devices. But Encase has a lot of capabilities. Next, please. There's a small video. Could we quickly run it?
We know you have a tough job. Mountains of data, people waiting on your investigation findings, and a never-ending backlog of new cases. At Guidance Software, the makers of Encase and pioneers of digital forensic investigations, we build our software with a deep understanding of the digital investigation workflow and the importance of maintaining evidence integrity. It defines our every process. No matter what you're handed, you need a powerful forensic tool that you can count on, giving you the power to find the unknown. Encase Forensic is used globally by thousands of investigators every day to perform successful investigations. Unlike other tools that may rely solely on what is visible to the operating system, Encase Forensic goes deep, finds more evidence, and allows you to triage digital evidence quickly, in the field or the lab to determine priority. Collect and decrypt evidence from a wide variety of devices. Process collected evidence in a consistent, automated fashion. Perform deep dive forensic investigation to identify relevant evidence, even deleted items. Create intuitive case reports for field agents, investigators, and others. There's no other solution that offers the flexibility, functionality, and track record of court acceptance as Encase Forensic. Discover how Encase Forensic can help you overcome your workload and complete your digital investigations. Guidance software from beginning to endpoint. Get a demo and quote today. Experts at Guide.
So yeah, basically, the E01 format that Encase uses is a very unique format. It has got built-in hashing. It will measure that no segment is corrupted. It will fingerprint every piece of information that is there. It can be compressed and stored, and it can be used on all sorts of file systems, including Linux. It can be used on Windows NTFS. NTFS is, of course, the new technology file system. And it can also be used extensively on things like different flavors of Unix. It can be used on Mac. It can be used with everything. And it gives you an insight. You can quickly see, say, if you're looking at a pornography case, within seconds, you can see every image that exists on the hard drive. Within seconds, you can get a timeline of when this image was added, when it was not added. Within seconds, you can actually get a list of every deleted file that exists. You can identify overwritten files, etc. So it's amazing. You can actually you can use this for recovering deleted data as well, and identifying when it was deleted, by whom it was deleted, and everything. Next, please. Okay, so like I mentioned, Encase, there's another tool for disk forensics called Belkasoft Evidence Center. So this is also similar. It works and uses the approaches that enable it to find most significant forensic artifacts and quickly, so that it helps you, solve your cases fast. And it provides very powerful analytical features, a connection graph, a timeline, advanced video and picture analysis, etc. Next, please. This is the process that follows it: acquire, examine, review, analyze, and report. Next, please. Portable is for triage. When you go on the field and you want to, figure out which computer to seize, which not to seize, this helps you do that. Next, please. This is for mobile forensics. Now, what happens is that when we are using this MD Live, it will quickly allow you to extract data from mobiles. It can give you speeds of up to 1 GB per minute, kind of a thing. Next, please. This you can have a quick look. So this is an additional tool which is also used for mobile forensics. Next, please. Next, please. Next, please. Yeah. Now, this is an important tool. This is basically used for social media analysis. This is the X1 social discovery. It is used for social media analysis. It can figure out what's going on the net. It will collect data from Facebook, Twitter, Instagram, YouTube, Tumblr, web pages, websites, Gmail, whatnot, and things like that. So from that perspective, for social media analysis, it can allow you YouTube, location-based search. It can actually allow you to search based on keywords and things like that. Next, please. Next, please. Then, this is Burla Blackthorn. This is a tool that is used for the purposes of GPS analysis. So if you recall, in 2611, there were a number of GPSs that were used. GPSs carry a lot of valuable information and it may not be connected to your phone. This is dedicated, even boats, fishing boats have GPSs, ships have GPSs, people carry handheld GPSs in the forest, wildlife crime and things, they're using GPSs and things like that. So from all that perspective, this is the tool that is used for the purposes of extracting data from GPS devices. Next, please. This is for video enhancement. A lot of digital evidence today is in video format. This is an example of a number plate that is not visible, but using AMP5, you can actually analyze and extract and get the image to some extent like that. Next, please. So here's one example of a, I think it was a Ola cab where the number plate was not visible, but there it was, using technology, it was an artificial intelligence, it was extrapolated and it has been able to be read. Next, please. This is a blurred image which has been enhanced so that it can be seen. Next, please. Sometimes, you cannot see the face of a person, but at least you can measure the height. So this can be useful. This allows us to measure the height of the person. So next, please. You need to, like, if you recall the Obama picture, it was difficult to identify, but using Authenticate, you can take a picture and analyze where, there has been cropping, cutting, pasting, and recompression and things like that, so that we can then identify what has happened. Next, please. This is an example of a tampered image. Here, images, the one on the left is the photo that we see. However, this was tampered and and when we look at it from an analysis perspective, we find this little L-shaped thing on that. So let's go next. The L-shaped thing actually was a pistol which was lying there and somebody took Photoshop and, cleaned it out so that you could not access it. Next, please. Video, today video evidence is huge. CCTVs have a lot of video evidence. CCTVs keep getting overwritten also. Normally we cannot get overwritten data, but this allows us to get overwritten video files, and artificial intelligence also allows us to recover numbers. Next, please. This is an example of an image where we want to identify, say, red cars or whatever, or trains or anything. We can do that. Next, please. So it will automatically detect those and see, as you can see this, it is highlighting those on the left. Next, please. It will look for objects that you want to see. Oh, there's a bicycle guy running around on a bicycle who would park his bicycle and steal a car or something. Next, please. And you can have target areas. You can identify vehicles based on colors and whatnot. Next, please. Here, this is an example for Mangalore police. There was a guy who committed a crime. There's a little case. And in that, the number plate was not visible. So it was analyzed and the number was identified. Next, please. Here, it gave some 5-6 options. And out of those 5 options, the correct number was found based on the make and model of the vehicle. Next. So it basically generates the probability of a number. Next, please. And then arrives at the correct number. Next, please. There are a lot of drones out there, and drones also allow us to get data. So we can extract data from drones. Next, please. Next, please. A product called MD drone, you can get all sorts of data from it. Next, please. Next. Next. Yeah. A lot of data stored on the cloud. You are all using, Google Drives. You're storing data on Google Drives. There's OneDrive. There are different types of things. There's iCloud. There's Samsung Cloud. The phones have drives. There's Evernote, there's Twitter, there's Baidu, all sorts of clouds are there. So one can actually extract that kind of data from the cloud using MD Cloud. Next, please. Next, please. Next. This is what it looks like, And broadly, I wanted to say that also, what happens is that we have situations where we have to, analyze a hard drive, for example. So when we are analyzing a hard drive, we have to create an image or a clone, and when we basically this is a type of duplication, and the reason why we are doing that is because we have to work not on the original, because the original will get damaged. We have to work on a copy, and when we work on the copy, what happens is that we can then, if anything goes wrong, we are not worried. So we create either an image or a clone, we do that, and we will then analyze it. However, the biggest problem that we faced is encryption. Windows comes up with encryption, BitLocker you must have heard of, but luckily it is not there in these home and lower editions. But professional, enterprise, etc., they've all got BitLocker and encryption, which is a built-in option. But before you ever create an image, you need to wipe your storage media, and that is basically means that you delete any existing data so that when you create an image, the old data is not superimposed. These are some of the things to keep in mind. Other than that, it is an amazing, amazing technology field where there are a lot of exciting things happening. And what happens is that when information security or cyber security fails, then digital forensics comes into play. And it is the last resort. So you can call, digital forensic guys are the surgeons of the industry. They will come in when the normal doctors have failed. So that's it for it. For now, these are my details. Do get in touch. You can connect with me on LinkedIn. Thank you very much.
Thank you, sir. Thanks a lot for giving a complete list of tools. So most of us might have not seen these sort of tools because all these things are used by police, law enforcement, pretty high tools. So participants, if you have any questions, queries, you can put it in the chat box.